All right, we are going to talk about 3.9 part 1, derivatives of exponential functions. So just to remind you, exponential functions are any functions with an x as an exponent. So y equals a to the x, where a is a number, would be an example. So sometimes we have a special number, which is e. E is like pi, where it actually stands for a number. We just
calculus.
write. That was Derby. Go away, Derby. And so we just write e instead of writing out the number, and then we're all good. So we're going to do some examples. We have our formulas here. The really cool thing about exponential functions is that the derivative of e to the x is e to the x. And that's the only thing that's like that, where the derivative is the same as what you started with. Now, if there's something in the exponent that's not just x, we'll have to times by the derivative of whatever's in the exponent. And then if you look on the right side, the difference when it's not e to the x is that we'll also have to times by the natural log of whatever our number is. So let's look at number 1. Y equals e to the x. The derivative of that is just going to be e to the x. So I would put y prime, or I could put dy over dx, and then I would write e to the x, and that would be my answer. On example 2, y equals e to the 5x. Now what I have in my exponent is not just x, so u is 5x, which means u prime, which is our derivative, is going to be 5. And so whenever I fill this in, I'm going to get y prime equals e to the 5x times my derivative, which was 5. And so what we'll do is we will rewrite that and put the 5 in front, so that my answer to this is going to be 5e to the 5x. On example 3, we have 2e to the negative x cubed. So what I'm going to do is I'm going to rewrite what I had to begin with. So that's going to be 2e to the negative x cubed. But then I have to times that by the derivative of negative x cubed. The derivative of negative x cubed is negative 3x squared. And then I'll rewrite this by multiplying the 2 and the negative 3 together. So this is y prime equals negative 6. I'll also put the x squared in front. Negative 6x squared e to the negative x cubed. And that would be my answer.
Are you talking back?
Let me erase this so that now I can do the other problem, because I ran into the room for the other problem. This erasing thing is not working out for me so well. So the difference on the next 3 examples is that we have a number instead of e to the x. So what that's going to do is it's going to change it so that we'll have a natural log of whatever number it is. And that's really going to be the only difference that we have here. So on example 4, this is going to be y prime equals, since the exponent is just x, the derivative of x is 1. So this is 5 to the x times the natural log of 5. I could put times 1, but I don't really need the times 1, so this is my answer. You can rewrite it if you want to, but you do not need to. On example 5, our exponent is negative 3x squared, so the derivative of that is negative 6x, and so that's what we're going to multiply by. So on example 5, our answer would be 7 to the negative 3x squared. Then I'm going to times that by ln of my number, which is 7. Then I'm going to times that by negative 6x. If you want to rewrite that, you can put the negative 6x in front, but other than that, we really can't do much of anything as far as rewriting. We cannot do 7 times negative 6 and get negative 42, because both of those 7s are protected by the things around them from being able to do that. So finally, example 6, 4 to the tangent x, u is tangent, and then u prime is the derivative of tangent x, which I'm sure we all remember is secant squared x. So this is going to be y prime equals 4 to the tangent x times the natural log of 4 times the derivative of our exponent, which is secant squared x. And again, you can rearrange this if you want to, but we can't actually combine anything. So that's pretty much it as far as this goes. So we're doing 1 through 14 on page 178, and that's it.